All right, let's look at a few more examples of solving equations with radicals. Look at example 2 with me. We have the square root of x plus 5 equal to 3. Remember, we want to try to get that radical by itself first. So let's get rid of the 5 by subtracting both sides by 5. When I do that, I end up getting the square root of x equals negative 2. Now we can get rid of the radical. We can get x by itself by, remember, squaring both sides. So I want to square this side, and I want to square the negative 2. You notice that I put it in parentheses because I want to make sure that I square the whole thing. The square and the square root cancel each other out on the left side. Negative 2 squared, that's negative 2 times negative 2, gives me positive 4. But remember, we should always be checking to make sure that our solutions work. If I take that 4 and plug it into my original equation, I end up having this. The square root of 4 plus 5 equals 3. And we want to make sure that this is true. Well, we know that the square root of 4 is 2, and 2 plus 5 is, 7, not 3, right? So what does that mean? Well, that means that x equals 4 is a solution, but it's an extraneous solution. It's actually a solution that doesn't work in our equation. So this equation, because x equals 4 doesn't work, means that there is no solution. There's never going to be a number that you can plug in underneath that radical, add 5 to it, to ever get the number 3. Let's try b. b says the square root of a equals negative 1. Now it looks like the square root is already by itself on that side. So if I go to square both sides, the square and the square root cancel, and I end up getting a equals negative 1 times negative 1 is positive 1. I end up getting a equals positive 1. Let's plug that in and see if it works. If I plug in a 1 underneath that radical, does it equal negative 1? Well, the square root of 1 is 1, not negative 1, right? And so a equals 1 also doesn't work in this equation, and I end up getting no solution. Look at those two problems. Do you notice anything about those two problems of why it didn't work? Well, maybe you noticed that any time I have a square root, it can't ever equal a negative number. Remember that underneath that radical can never be negative. So no matter what number I put underneath here, for example here, if I try to put in a 4, the square root of 4 is 2, not negative 2. Or if I try to put a negative 4 in there, oh wait a second, there is no such thing as the square root of negative 4. That doesn't work either. And so anytime we see that, as soon as that radical has a variable underneath it, square root of x, and it's equal to a negative number, we know that there is going to be no solution. We might get a solution. That's why it's important to check, so that I know that it's actually an extraneous solution and actually doesn't work. So be careful with that. Make sure that you're on the lookout for any of those types of problems. All right, in this video, let's do one more example. Now you can see, example number 3 is a little bit challenging, okay? So again, you might need to pause the video, you might need to replay the video, you might need to try these ones a few times to make sure that you fully understand, okay? All right, looking at example number 3a, it asks us to solve. And you notice that this one looks a little bit different than the ones we've done before because we have an x underneath our radical and we have an x on the other side. We have two variables, right? Two of the same variables, but still two x's in one problem. Now our goal is still the same as before. We want to try to get that radical by itself. And you notice that there's a positive 5 that's over here. So let's go ahead and first move the 5 to the other side by subtracting it. When I do that, on the left side, I have an x minus 5 equal to, and then I have the square root of x plus 7 on the right side. Now that my radical is by itself, we should be able to get rid of the radical, just like we've done before, right? We can get rid of the radical by raising it to the second power. But remember, we have to make sure that we raise both sides to the second power. So be careful. I want to make sure that I raise both whole sides to the second power. The square and the square root are inverse functions of each other. They should cancel out. So left on the right side should be an x plus 7. But now look at the left side. Be careful. Please don't distribute the squared to both things. Because there's a plus or minus sign, remember, when I have an x minus 5 squared, that really means that I have an x minus 5 times another x minus 5. And the only way to get the correct answer is to FOIL. We cannot just take that squared and square each individual piece. We have to FOIL that left side. When I do that, I end up getting x squared minus 5x plus 25 equals x plus 7. I have no more radical, but I have lots of different variables. Let's go ahead and see if we can combine like terms. I notice on the left side I have a negative 5x and a negative 5x, which is really a negative 10x. I notice that I have x squareds and x's. And as soon as I notice that I have x squareds and x's, I know that this is a quadratic, and I want to try to move everything to the same side and try to factor. So I'm going to go ahead and subtract x and subtract 7 so that I can move everything over to the left side and set it equal to 0. When I subtract x to both sides and when I subtract 7 to both sides, I end up with x squared minus 11x plus 18 equal to 0. And now I can use my techniques of factoring like we did, I think it was back in chapter 5, right? It looks like this is a basic factor problem. I need numbers that multiply to positive 18 that add to give us negative 11. I end up getting x minus 2 and x minus 9. I still want to figure out what x equals, so I'm going to set each of those equal to 0 and solve, and I get x equals 2 and x equals 9. That was a lot of steps, so be careful. Again, we isolated the radical, got the radical by itself. We squared both sides to get rid of the radical, but that meant we needed to FOIL that left side. We combined all of our like terms. We moved everything to the same side so that we can factor in order to solve for x. Now, just when you think we're done, we're not. We have to make sure that we check both of those answers to make sure that they both work and they're not extraneous. So let's take 2, plug it into my original equation, and see if it works. I have 2 equals the square root of 2 plus 7 plus 5. Let's see if that's true. Well, this 2 plus 7 is 9. The square root of 9 is 3. And 3 plus 5 is 8. Which is not the same thing as 2, right? And so the left side doesn't equal the right side when I substitute in a 2. So that means 2 is an extraneous solution. It's not a real solution that works in the equation. We get it, but it doesn't work. So what about 9? Let's take 9 and plug it into our original to see if it works. If I plug in a 9, 9 plus 7 is 16. The square root of 16 is 4. And 4 plus 5 is 9. And 9 equals 9, so it does work. So I get an answer, but I just get one answer that works, x equals 9. That's why it's really important to double check your answers in your original for all of these radical equations to make sure that we don't have any extraneous solutions. Okay, let's try one more. Let's look at B. B says we have 5y plus 31 to the 1/4 power minus 2 equals 0. 1/4 power. That kind of looks weird, doesn't it? It looks like we have a fractional exponent. But we know from previous sections that a fractional exponent can actually be changed into a radical, right? Remember, top dog goes in the house? So I can take this 5y plus 31 to the 1/4 power, and I can actually change it into radicals. I can really say that that's really the 4th root of 5y plus 31, right? Minus 2 equals 0, of course. Now, this is a radical equation, and I can follow my steps for solving a radical equation. I can get the radical by itself, by adding 2 to both sides. I can get rid of the radical. Now look at this one. If I want to get rid of a 4th root, I can't square both sides. I have to raise it to the 4th power. So that way the 4th power and the 4th root will cancel each other out. So be careful with that. If it's a cube root, you're going to cube it. If it's a square root, you're going to square it. But now that it's a 4th root, we're going to raise it to the 4th power. So on the left side, the 4th root and the 4th power cancel each other out, and I'm left with a 5y plus 31. On the right side, I have 2 to the 4th power. That's 2 times 2 times 2 times 2. I got 16. Now I can solve for y. I can subtract 31. I can divide by 5. And I ended up getting y equals negative 3. All right, but let's check. Let's take this and plug it back into our original equation. And maybe not our original equation with the 1/4 power, maybe the equation that we use when we converted it into radicals. It might be easier that way. Remember, it's the same exact thing, just a different form. So I'm going to actually take this y equals negative 3 and plug it into the radical version of my original problem. I'm going to plug in negative 3 and see if it works. 5 times negative 3 is what? Negative 15? Negative 15 plus 31 is 16. Now we've got to figure out what the 4th root of 16 is. What number multiplied by itself 4 times gives me 16? You should get 2. And 2 minus 2 is 0, and it works, and so I know y equals -3 is the correct answer. We don't have any extraneous solutions on that one. Ooh, those are some two good ones, right? Make sure, if you weren't sure on any of those steps, that you go back, you rewatch the video, maybe even try it again all by yourself to see if you can follow all the steps from the beginning to the end, making sure that you get the same solution that I